Okay, I had an error in what I said. There was one step I didn't get here. Matrix times y equals the derivative gives us this equation where you have a characteristic matrix times your column vector x1, x2 equal to the 0 vector. Okay? So we get characteristic matrix times your x vector equals 0. And now the matrix has to be non-invertible to give us a solution. Because if your characteristic matrix was invertible, we could invert it, multiply it by 0 and get 0, so the x vector would have to be 0. So we'd have a trivial solution. Okay? And of course x is your x1, x2. So applying this, and this is your scheme. Applying it is simple enough. We take the derivative of the y expression. x1, x2 is constant. And we get this. And then we multiply this by the matrix. And we get y prime equals this. And we set this equal to this. The e to the lambda t divides out. So we get this matrix times the x vector equals lambda times the x vector. We subtract the right-hand side from the left, write it as a matrix, and we get this. So we need to understand that that's what we're doing. Now, this then has a solution if and only if the determinant is 0. If and only if, in other words, this matrix is non-invertible. Because again, if it was invertible, we'd invert it and multiply it by the 0 vector. We'd find that the x vector is 0, so the y solution would be 0. To get a non-zero solution, maybe I should say that, non-zero solution, if and only if that determinant is 0, and that is our, I call this our characteristic matrix. This is going to give us our characteristic equation that we can solve for lambda. Having solved it for lambda, we generally expect 2 solutions, although we could have a repeated solution. And that's a case that we're probably not even going to cover because we're going to get into Laplace transforms a little deeper. And it's somewhat complicated. Again, one of those things that if you ever need to do it, you can read up on how to do it. If you understand all this, then presumably you'll be able to understand how to deal with the repeated solutions. Okay. So I was going to say something else, but that's enough right now. So let's get the lambdas, right? If you get 2 lambdas, then each lambda is going to give you a different x1, x2. Actually, they might give you the same x1, x2, but you'd have different lambdas, right? So could that happen? Well, you can think about that.